Cities matter. They are the engine of the global economy and are already home to more than half the world's population. Urban passenger mobility is now an important area of research in decision sciences. For the urban passenger, the connectivity at the last mile with the dominant public transit system has assumed critical significance. My dissertation seeks to investigate specific problems related to the adoption and usage of modern public transit systems due to gaps in serving the passenger at the last mile. I identify and dissect issues at the last mile and build on from existing theoretical frameworks to solve some of the critical problems in urban passenger transit. The first part of my thesis builds the case for comprehensively planned fixed route last mile feeder networks that prioritize quickness, affordability, and reliability of services. I use these insights to develop a replicable framework which quantifies access, identifies gaps in coverage, and defines a last mile structure to address connectivity issues. I use the metro rail in Bangalore as the case study for the work and demonstrate results within that scope. In my analysis, I find that the proposed long-term metro rail covers only about 43% of the city's population within a walking distance of 1 kilometer from the nearest station. Using a combination of spatial analytics and computational geometry, I restructure the metropolitan area to identify unique subzones and last mile stops proximal to metro stations. I then use optimization algorithms to design feeder network routes over which last mile services could operate, thereby increasing coverage to more than 90%. The latter part of my dissertation looks at the problem from the passenger's perspective, as I seek to understand passenger behavior over the last mile transport choices in greater detail. Continuing with Bangalore Metro as my case study, I attempt to arrive at value propositions for fixed last mile feeder services with the objective of inducing a fundamental change in passenger behavior in adopting public transit over hired personal transit and personal vehicles. I'm working on a conjoint analysis based choice modeling methodology to arrive at these actionable insights. Personally, my dissertation is an exciting intellectual proposition for me as it contributes to literature across varied disciplines of transportation, optimization, marketing, and even public policy, while focusing on an extremely relevant real-world issue.